What is the meaning of that? If you take any number m integer, it can be written uniquely as a prime factorization. Okay, we are going to now show that we can express this as the product of primes, and we are going to show that it is unique. We are going to show that it is unique. Now, when you uniqueness exists as prime, if n is prime, then automatically what is that? N equal to p, and p cannot be written as any other. So it is there is nothing to prove. If n is not prime, then what is that? N is automatically it is a composite number. What is meant by composite number? Product of two numbers, a, b, and whether a and b they lie between 1 and n. So a is a number lying between 1 and n. B is also a number lying between 1 and n. By induction, we have just now assumed that it is true for any integer m lying between 1 and n. Therefore, a and b can be expressed as a product of prime factors. Now, therefore, we are now going to prove that it is unique. N equal to what? It is ab. We are going to show that it is having a unique prime factorization. If possible, assume that n has two factorizations. Namely, one is n equal to p1 to the power of a1 into p2 to the power of a2 and so on, pk to the power of ak. Similarly, another product we are going to consider prime factorization, q1 to the power of p1, q2 to the power of b2, etc. ql to the power of bl. Now we are going to show that these two are the same. That means we are going to show that k is equal to l, and also we are going to show that pi is equal to qi, and also we are going to show that pi equal to bl. In order to prove this, now consider because both are same n only, we write p1 to the power of a1, p2 to the power of a2, etc. pk to the power of ak equal to what? q1 to the power of p1, q2 to the power of p2 and so on, ql to the power of bl. And pk to the power of ak can be written as pk to the power of ak minus 1 into pk. You can write pk to the power of ak means what? How many number of times the product pk is repeated ak number of times. Suppose p5 to the power of a5. What is the meaning of that? p to the power of a5 into p to the power of a5 into p to the power, like that 5 times. So here we can write this as pk to the power of ak minus 1 into pk. Similarly, now we are having that is similarly ql can also be written like this. Okay, we have taken ql to the power of bl. Here only we have taken as a product of two numbers. Now what is this? pk I am going to write it in the beginning. So what is this? q1 to the power of b1, q2 to the power of b2 and so on, ql to the power of bl equal to pk times p1 to the power of a1, p2 to the power of a2, etc. pk times to the power of ak minus 1. Now what is happening? Now this number is written as product of these two. That means pk divides this product q's. pk is dividing the product of q's. q1 to the power of b1, q2 to the power of b2 and ql to the power of bl. Now it is product of prime numbers. By the previous theorem number 9, we have seen that if pk is going to divide the product, then it is going to definitely divide at least one integer. So pk divides either q1 to the power of b1 or pk divides q2 to the power of b2 or pk divides ql to the power of bl. This comes by Euclidean lemma. Now once again bring back n equal to what? pk into, we can write b1 to the power of a1, p2 to the power of a2, pk to the power of ak minus 1. And what is another representation? q1 to the power of b1, q2 to the power of b2, etc. ql to the power of pl minus 1 into ql I am writing here also. So what is going to happen? N equal to pk into, once again, the product of these numbers into, similarly here I am going to write, because pk is dividing one of this number, and instead of ql I am going to write that as pk. Okay, so what is going to happen? Here also we are having pk, here also we are having pk. So n by pk equal to what? p1 to the power of a1, p2 to the power of a2, etc. pk to the power of ak minus 1. Here also we are having q prime number, this automatically this greater than 1 since pk divides n. So we are having this number n by pk. It lies between 1 and n. Whenever it lies between 1 and n, we have shown that it can be written as product of prime factorization. So by hypothesis we are having n by k equal to, definitely it is equal to some m we can write. Therefore it is having a unique factorization. We have shown that n is equal k equal to l, pi equal to qi, I equal to. I hope this